a few interesting questions were asked on the break. Question number one, so what do we do with the legacy code? You know what is legacy code, right? Legacy code is something which you inherit from the previous team, or when you join the team, and which happened to me a few times. When you join the team, they just hire you and they say, you're a great programmer, so please join our team, let's work together. And you open the code base and you realize that these people never used any style checkers, they never had any sometimes even any unit tests written. And your job is to continue working with that. And you regret the moment when you accepted the job offer, but you have to continue. So the first step you start doing is solving the problem and introducing the style checkers somehow. And of course it's extremely difficult because there are sometimes 100,000 lines of code, and you don't have the time, the energy, the money, anything for fixing those thousands or sometimes tens of thousands of complaints if you run check style, for example, or Rubocop. And Rubocop is better because Rubocop can automatically fix, but check style cannot automatically fix anything, and you just have to sit and fix, and sometimes you can break the code. If you fix, while you're fixing the style, then you can break the code. For example, I can give you a practical example when this may happen, because style is not always about spaces and indentation and brackets. For example, check style will complain if your method has more than 3 parameters. And if your method has 5 parameters, then check style will say there's too many, so only 3. That's the maximum. So what do? You need to somehow find a way to break this method into 2 methods, or maybe provide, instead of 5 parameters, provide maybe some object there which contains these parameters, maybe some, I don't know, something. And by doing that, you will refactor the code, you will change the code, and you can introduce some bug. And if this code is not covered by the unit test, then very likely that you will break the production server. If it's one instance, if it's one case, then maybe it's okay. But if it's like hundreds of cases over the legacy code, then you're in big trouble. So how do you do? But you cannot say no. You cannot just say this code is not suitable for style checking, which some people do. Very often I see teams, when I ask them, why do you don't use any style checking, then they say we cannot because it's a legacy code. So we basically got this code from previous generations of programmers, so we just live with that, and the code is dirty, but what can we do? So my recommendation is to incrementally incorporate style checking into the build by first injecting it there with very limited set of rules. For example, first we just check that indentation is done by spaces, not tabs. Is it fixable? It's fixable. No matter how huge is your code base, you can replace tabs with spaces. You're not going to break any code. Well, maybe you can if the tabs are inside the strings, right? Then if there's a string there, then probably the tab stays there and you replace it with spaces. So maybe you can break production, maybe. But it's still doable, and it's not going to take you days to make this change. You make this change, you introduce the style checker, and from now on, only the spaces can be committed to your master branch, because the style checker will say no to the changes which introduce tabs. The next step, you say, okay, from now on, we disallow the variables, names of variables of just one symbol, like in my example, I, O, J, that kind of stuff. Only 3 or more. Is it difficult to fix the code? In this case, to modify the code. Maybe not so hard. It will take some time, but again, this change is more or less routine. So you can ask some programmer to make these changes, spend 1, maybe 2 days to go through the entire code base and change the names of the variables. Next step, and so on and so forth. So step by step, you will eventually make your style checker strong enough. Don't put the style checker with the full force. Don't put it to the maximum. So legacy code is a problem, but not a fatal problem. It's solvable. Just step by step do it. And the second question is, which is also very frequently asked, is when you have the style configured in your for example, in check style configuration in the code base. And then you have IntelliJ or Xcode or whatever. You have the IDE where you design your code, develop your code. And the style which you have here and the style which you have in your repository, they differ. They're not exactly the same. For example, if you go to IntelliJ, there's an option for automatic code formatting. So you can click auto format the code and IntelliJ will format the code the way IntelliJ thinks is right. And then when you go to check style, the check style will complain about that. And very often programmers, when they join our projects, they ask the question, can you please give me the settings for IntelliJ so that I use them and I just click one button and format the code so that your coulisse doesn't complain. And we don't have this configuration. So that's what's almost unsolvable problem in my opinion. So your IntelliJ, your IDE, maybe not IntelliJ, your IDE, you will be somehow disconnected from the checks which are incorporated into your build. And this connection is almost impossible to establish in my practical experience. So which tells me that maybe it's not a good idea in general to rely on the formatting style of the IDE. So IDEs, they very often make mistakes and very often the way they format code is not perfect, but if you rely on them, then you will miss the important element of the style checkers, the education. So when they express their concerns about the style of your code, they teach you. And I even some time ago wrote a blog post about that. Let me show it in the chat. Maybe you will like it. I even called it educational aspect of style checking or something. Yes, that's like 5 years ago, or 4 years ago. So I said that, so when you write code and then you send your code to the style checker is like a mentor for you. It's like a teacher for you. It just tells you back what's wrong with your code. And when they say what's wrong with your code, they usually explain it in details. They give you the explanation. Sometimes they even give you the link to the blog post or whatever, which explains why this is wrong. And you read it and you learn. I can tell you, I started learning Rust programming language about 8 months ago. And first of all, I read the book. Well, not entirely. But I read maybe half of the book, I understood how the language works, and then I went into coding into language with Rust. And the first thing I did, I started to use I started to see how Rust format the style checker, what it thinks about my code. Actually, Rust may be not a perfect example because they have auto formatting and. Yeah, but actually, yes, exactly. The Rust will complete. I was writing the code, and the style checker, which is incorporated into Rust, which is in Cargo, right? It's Cargo FMT, yeah, right? Yeah, Rust formatting. I think it's Cargo FMT. Yeah. So this FMT this command will tell you what's wrong in your code, and this is the best teacher you can find, in my opinion. So you write the code and you know how it works, you know how to make the functionality, but you don't feel the language. You don't feel what's right, what's wrong in the language. And all languages, they allow you to write the same functionality different ways. And they allow you to write the good style and to write the bad style. But the style checker will kind of teach you what is right, what is wrong. And I was listening to this formatter for quite some time. And finally, I got the feeling of, well, I think I got the feeling of what is good, what is bad for Rust environment, for their style of writing code. So when you ignore that, when you just jump into automatic fixing, when you just run the IntelliJ or IDE with the auto formatting and say, format it for me, I don't care. Just let me click the button, just do it right, and that's it. And let's push it to production. You kind of miss this educational element. So by suffering through by the suffering you get from pleasing the style checker, you learn what's right, what's wrong in the language you use. So my suggestion, don't rely on auto-formatters. It's a bad habit. Unless you're doing what I told you, what I showed you before with the Rubocop, when you just switch from one version to another, then you maybe want to auto-format. But still, I would suggest you to read what they complain about, just to understand what's going on, what was changed, why they complain now about the code, which they didn't complain before. What's new? Just learn it. And then, of course, if you have auto-formatter, then maybe not to avoid the routine operations, you just run it all together. So this may be the answer of the... And also there is another feature which I can tell you, I just discovered it just recently, the feature in IDE, in IntelliJ, for example, which allows you to fix multiple problems in the code with just one click of a button. I can probably, like for example, here we have the problem in the code. It highlights me. And by the way, in IntelliJ, for example, that's my favorite IDE. That's why I'm talking about it. So IDE in IntelliJ, you can configure also style checkers, not only on the check style and PMD or whatever, but you can configure it inside your IDE. So my suggestion, in your IDE, turn on all the possible checkers, all the possible settings, the strongest, make it the strongest. So when you start using the IDE or you already have the IDE, go to settings, find the configuration where you can enable all the rules and turn them on. So for example, inspections. So let's go to settings and find the inspections I have. Inspections for Java, I guess, here. So this is the list of inspections which IntelliJ provides to me. So code style issues, you see? So in my case, not everything is turned on. Not everything, but the majority of them. Constant on wrong side of comparison. Yeah, why not? Chained method calls. I don't know, maybe some of them I already disabled because I use it for years. But ideally, you turn everything on. Everything. So you to the Java, you click the button here, and all of them will be on. That's what I suggest doing. Because by default, when you install IntelliJ, it will go with not everything turned on. By default, actually, only the minority will be turned on. That's my, maybe I'm wrong, but that's what I got, I believe. And then you just make more and more and more. For example, magic number. This one I turned off because I believe this is not a good one. But public method not exposed in interface. Maybe I should review that as well and turn more of them than single class import, and so on and so forth. What is interesting, so that's my suggestion to you, turn everything on. And second, the feature which I didn't know about, so for example, this is the wrong way of writing the call, I believe, and IntelliJ agree with me, and the check style as well. So the right way is to say this.log. And then it becomes not read. Why? Because in this case, it's obvious that you are referring to the method in the class, while in this case, it's not so clear. Maybe it's a variable somewhere in the code, maybe it's something else. So usually it's a good practice to do it always like this, to mention that you're referring to something in the class. But here it's not. So it's possible to do like this. It's possible to do it automatically, add qualifier, and it will just write it for me. What is also possible is to do this. Then bottom right, run inspection on, and the whole project. And it will find the same problems in many other places in the project, show me the list, I will just do it like this, and boom, it will fix immediately all the files. So what you can do when you open legacy code, you just open one file, you find the problem which you see here, which IntelliJ identifies, you point on this problem and ask IntelliJ fix all similar problems in the entire code base. And actually also they have this option, clean up code. So you can say clean up code on the whole project. In this case, it will fix many problems, not only this one, but a big number of problems on the entire code base. So this is more or less like automatic fixer. You see, it made many changes. So many files were affected, which I believe is a good practice. See, it changed something here. Again, it added this. With the legacy code, this may help. Automatic filter, automatic fixing of problems. Okay, and now let's try to create our own GitHub action, which would be. So again, let's go to GitHub Actions. Who of you ever created your own GitHub action? 1, 2, 3. 3 people. Okay. So others may learn something interesting. Okay, here we don't need this, right? So I just like that. What do I do? Okay, that's it. So we already discussed the actions. So let me show you again the example of an action. Yeah, it's not here, it's here. So this is the configuration in GitHub for how to, it's basically a workflow. It's not an action, it's a workflow. So this workflow defines a sequence of actions, a sequence of things to do, of steps to do, or like they call it steps. So each step, like I showed you before, each step is a repository name, is the name of repository on GitHub. This is the name of repository, this is the name, this is the name, and this is not the name because it's run. So run actually is the command on the command line which is executed in the server, where it's run, in the virtual environment. When you say uses, then you just point to a GitHub repository where to take the code and run. So sometimes it's interesting and important to write your own repository, your own place where you define the same actions. Why it could be useful? For example, you have multiple projects, and in multiple projects you do the same. You do the same set of operations. You can either write it like this here with the run, but if you do it multiple times in many projects, then you will have to repeat it again and again. You don't want to do that. You want to place it in some place and then call it from all your workflows from different projects. That's one reason. Reason number 2 is that sometimes your operations are expensive. So for example, in this case, it's not expensive, it's basically a build. But let's say you want to install many things there. For example, you want to install some very heavy package, maybe compile it for a few hours, prepare everything, and then run your build. For example, you want to install LLVM, the custom version of LLVM, the virtual machine. And that will take you a few hours to compile it with the custom configuration. You don't want this to happen on every build. So you push something to master branch, and the GitHub picks up this workflow and starts compiling LLVM from scratch. But this is exactly what will happen if you put this LLVM compilation step right here in the run command. You don't want that. You want to create an action. You want to create an action which, this is how it's designed in GitHub, which will be pre-executed in the Docker container, and the resulting Docker image will be cached by GitHub. And GitHub will pick it up every time you need to use it and will use it for your own workflow. So how you do it? For example, I can show you how I did it some time ago for LaTeX. So I created an action which you can use like this. So for example, you need to have, you have a LaTeX document in your repository and you want this document to be compiled using LaTeX. So it basically will require you to do some operations, so you don't want to do it manually, so that's why you can use it just like that. You can say uses, and then the name of my repository with the fixed version, and then you configure it with the commands. So here, if you design the workflow like this, then it will just compile the LaTeX document and create the PDF file. So how I did this? I created the configuration file in YAML format, which describes my action which explains what it does, which designs some branding. It shows what's the color of the icon and whatever. It explains that it runs with Docker, and my Docker file is here, and also designs the parameters which can be provided to it, like the parameters in your YAML. Then I designed a Docker file. Pay attention, it's a Docker file. So I said what to install, and you see this is a pretty heavy operation here, which is called, yeah, well, I'm using this another image here, which also pretty heavy. So this image already has installed LaTeX, which takes maybe, I don't know, maybe 20 minutes to build this image. And then I install some additional tools. I make this also pretty, time-consuming operations here. I install some packages from Python. And finally, I have the prepared Docker image, which then will be used by the action. And I also configure, well, that's probably it. I also configured the testing. So this stuff is also self-tested. So I designed the test. You may find this interesting if you want later. Well, it's going to be in the video. So you can find this repository if you like, which will show you how it's done. And now I'll show you how we use it in how this action is being used in the real workflow. For example, here. So you see, I'm using my own action here. I compile LaTeX document, which is located in the location paper. I installed these additional packages, whatever. So let me show you how it's being executed. What is the result? So if you go here, then the latest execution was yesterday, actually. So this is the build. And this is my action, which does all the commands which you saw before in the Docker file. You see it installs the dependencies and builds the boom, boom, boom. Takes some time. It builds the LaTeX document, and in the end, some errors found, but whatever. These errors are not fatal. So that's it. So GitHub workflow is the place from where you call the actions. And the actions you can create yourself. Each action can be created yourself, and this is really a good strategy for designing GitHub workflows. And one final interesting point I want to make is, do you know about hosted runners on GitHub workflow? One of you knows, but for others I will explain. So when GitHub starts those machines which we're discussing in order to execute your code, GitHub provides you the machines for free. So well, actually Microsoft provides you the hardware where everything happens. Sometimes it's not enough because GitHub will not like your builds if they take too long. If your software needs, for example, 2 hours to build everything, then GitHub will tolerate this for a few days, but then you will get complaints and probably GitHub will start restricting you because you consume too much resources. That's one problem. And the second problem, the builds you run will not be repeatable. I mean, their performance parameters will not be the same between executions. So on the first execution, the GitHub may give you fast computers. Tomorrow, they may give you slow computers. But if you want to compare the builds, if you want to collect some performance metrics, then you want your builds to be of the same, well, have the same hardware. So that's why you can give your computers, you can give your hardware to GitHub. You can tell GitHub that please use my machines. And I can give you a real example where we needed that. So here's the repository. The repository is doing this. It's a pretty interesting experiment we did. So we took the Fibonacci algorithm. You know Fibonacci, right? How to calculate the Fibonacci number. And we implemented this algorithm using multiple languages. For example, we implemented it using Ada language. This is Fibonacci in Ada. Who knows Ada, by the way? Who knows about Ada? Okay, so half of you knows the name of this language. Actually, it looks very similar to, in my opinion, to Pascal. This is Ada. This is Fibonacci, recursive Fibonacci algorithm in other language. So we implemented it in other. Then we implemented it in Pascal. There. Recursively. This is Pascal. Who knows Pascal? Who ever wrote real code in Pascal? Good. And how come? You're young for this language. I mean, this language was like 10 years ago, retired, no? In school, that was like for education, okay. Because I remember the times when we actually wrote real code in Pascal for real production software. So we wrote this in Pascal. We implemented Fibonacci in Pascal. We implemented, of course, in C++. Well, we actually implemented, you see how many possible ways we implemented Fibonacci algorithm. So each file, it's a different implementation of Fibonacci algorithm. Recursively, through the functions, through the matrix, inlining the code, not inlining the code, using objects, using stack and objects, using objects on stack, using static members. So all the different ways. For example, this one is very simple implementation of Fibonacci algorithm, which is, not very traditional, but one way of implementing it. Another way, it's a completely non-recursive using matrices. Also Fibonacci. So many languages, but a few languages. Lisp, for example, we did it in Lisp. This is Fibonacci in Lisp. So who knows Lisp? Just 1, 2, 3, not enough. Lisp is, in my opinion, the most beautiful and powerful language. So this is Fibonacci in Lisp. It's a functional programming. Well, actually, this is Fibonacci in Lisp. But the rest is for running this code. Because every file we have in this repository, it's a standalone program. So it's not just algorithm in Lisp. It's actually the full software, which you run from command line. It prints the results, and you read the results. And that's not it. So we implemented that in multiple ways, and then we compiled all of them into binaries, and then we executed them, calculating how fast are them, who is faster. So it's a competition of algorithms and programming languages. So which language is faster? Which language makes the faster binary code, which can do exactly the same. So we run them all the same, and we built this table. So look at the numbers. So this is all algorithms, all implementations of the same algorithm. And on the left, we have the name of the language / the name of the algorithm. Here we have the column which says how many assembly instructions this function generates when being compiled, when it's possible, because some compilers, they don't give us this information, some compilers, they give. Here we show how many times we ask this code to calculate the Fibonacci number, the 32, the 32nd Fibonacci number. So for example, this algorithm, this Pascal recursion, we ask the algorithm 256 times. So we ask it to calculate the same Fibonacci number 250 times. Why? In order to, to collect some statistics and then divide the total time by the number of executions and calculate how fast was one execution. But some algorithms were extremely fast. And that's why in order to calculate the time of one execution, we needed to run, for example, Go. In Go, we wrote this algorithm in a fast implementation, which actually the winner in this case. Well, yeah, I guess. So 1 second it took to calculate Fibonacci number 33 million times. So we said 33 million times, calculate the 32nd Fibonacci number. And this algorithm did it in 1 second. Just boom, 33 millions, just 1 second. So that gave us the number that this column means how many SPC cycle, S means, S stands for SPC, how many seconds per each calculation. Yeah, so basically this is how many seconds it takes in Go using this algorithm to calculate 32nd Fibonacci number. So in this algorithm it's nanoseconds. In this algorithm it's 152 seconds. So that's a huge difference between the fastest algorithm and the slowest one. And then we calculated how many CPU ticks it took to calculate, and then how many ticks per cycle, and this, and that's it. So we run it. So obviously, in order to, and this table is built automatically every time I make a push in the master branch. So if I go to this repository right now, if I change a little bit something, I make a push to the master branch, GitHub will start this entire pipeline, will recompile all algorithms, will run them all, and calculate the statistics, and generate the new table, and publish it on GitHub pages. That's how it's designed. But I didn't want this to happen on GitHub hardware, because if it would be this case, every time I would get new numbers. Every time this table would look differently, because every time GitHub would give me the different machine, the different computer. That's one problem. And second, that would not be bare metal computer. That would not, it would be just virtual machine. And there would be no guarantee that the numbers are correct, because the time would not be right. I mean, we would not know for sure that that 1 second the computer was not doing something else. It would be just, instead of 1 second, we would see 10 seconds, but not because the algorithm is slow, but because when this algorithm was executed, the GitHub started something else, started another virtual machine. And on this virtual machine, something else was happening. And that's why we got 10 seconds instead of 1 second. So we needed to give GitHub my server, my computer. And I did. How did I do it? You can go to Actions, if I'm not mistaken. Hold on, it's in Settings. And then you go to Actions. And then you go to Runners. Oh, there are no runners configured. Interesting. Oh, maybe we, at that time, because the last time I generated this table, it was in March. So probably after that, yeah, not probably, definitely. After that, we reinstalled the server, so we didn't run it after that. But if you want, if I would run it right now, then I would do it like this. I would say new hosted runner. You create new hosted, they call it self-hosted runner, which actually means the actual server. Then you say, for example, you have Linux, and you say your platform, and then they tell you how to do it. So you have to go to the server, you have to do some, some dancing with the files, set up some configuration scripts, and then your server, with this token provided, so you provide the token here, and your server with the installed software will connect to GitHub, and they will, and the server will say, I'm ready to take jobs. And then GitHub will say, okay, stay listening for that. And as soon as something shows up, it will drop that job on the server, and your server will run what's need to be run on your machine. It's quite popular mechanism for that kind of situations. And also I know one case when we also used that. It was when we wanted to use a private set of private resources, private services during the build. And if you do it on GitHub, you cannot do it because GitHub will try to connect to your services from public internet. So to solve that, you install your machine, special machine, especially intended for that, for running builds. You install this machine inside your private network, inside your virtual network or whatever, which is disconnected from the internet, which is behind the firewall. And on this machine, you can do whatever you want, but this machine connects to GitHub, and the GitHub will only send commands to this machine. So from the outside, it looks like a public open source project, but in reality, the build is run on your virtual machine, which is behind the firewall. So sometimes you may need that when your project involves private, whatever, secret resources. So we have a few more minutes, maybe questions, maybe ideas. Did I tell you something new today? Raise your hand if I did. Just one? Okay, not one. That's good. Okay. That was more like introduction, so we will talk about more difficult stuff next time. We'll talk about, probably next time we'll talk about managing dependencies, dependency hell, maybe you know what it is. We'll talk about how to release your dependencies on public platforms like Maven Central, NPM, PyP and whatever. And we will talk about, mostly about dependencies. That will be the subject of the next lecture. Okay, see you soon. And remember what we're looking for, start doing some project. If you need some topics for interesting projects, come to me, I have a few ideas. If you implement them, you will do good things for our open source community, for the topic we're working on. So if interested, just text me on Telegram and I will give you a subject. We can do it together, I will help you. In this case, you will do something meaningful. But if you don't, just make a group, find a topic, and start increasing quality in your code. Thanks a lot. See you in 2 weeks. Bye-bye.